In the last video, we made holograms in ShaderGraph, and today we're going to add two imperfections to give them a bit more character. We'll base everything off the shader we wrote last time, so I'd recommend watching the previous tutorial first. Before we get into the meat of this video, let's fix a problem with the shader. Even though a hologram is supposedly made up of pure light, our holograms receive shadows. Disabling shadows in ShaderGraph and URP is a bit more cumbersome than you'd expect, so bear with me. Open up the shader and add a new boolean keyword. It needs to have a reference called _receive_shadows_off. The capitalization and the position of the underscores is important. The whole thing is in all caps. Then, to use this keyword, we need to select the material using the shader, go into the inspector's debug mode using the tiny 3 dots menu and select debug to show some hidden settings. In the shader keyword section, type receive shadows off with the same capitalization and underscores as before. Now the hologram should be free of shadows. With that out of the way, the first effect we'll add is Distortion. We're unable to physically move the position of every pixel of the object, but we can move the model's vertices. The PBR master node exposes vertex position, normal, and tangent pins. We'll be modifying the position. Unfortunately, this also means the effect won't look great on low poly models, so for the purpose of this tutorial, I've imported a high poly sphere. If you're using the shader on a character or a landscape, you'll probably be fine. Start off by adding a vector1 property called glitch strength to control how far the distortions extend. I gave it a default value of 0.1, but it doesn't matter too much. We'll need a position node to get the object space position of each vertex, which will immediately feed into a split node in order to get the Y component. What we're going to do here is use noise to add a pseudo-random offset to the vertex position, but we want to seed the random generator using the Y position so that the offset for two vertices on the same Y elevation is identical. With that in mind, feed the Y component, or in this case the G component, into a simple noise node's UV channel. Multiply its output with the glitch strength property and use this as the X component of a new vector3 node, leaving the Y and Z as 0. So far we've calculated a horizontal offset value. We want the offset to be applied relative to the camera view direction, or else our hologram will distort in world or object space and look weird when viewed from certain angles. From the original position node, drag out a transform node and convert from object space to view space, then add the offset value to it. We need to convert back to object space using a second transform node, nimbing an output directly to the vertex position pin on PBR master. We can now distort vertices, as you'll see in the preview window. For the second imperfection, we'll be using simple noise again, but in a different context. We'll make the hologram fuzzy by blending the noise with the scanline texture. Start by adding two vector1 properties. One's called noise scale and it has a default value of 500, and the other is called noise strength with a default of 0.5. Using the multiply node from the previous tutorial, drag out a new vector2 node and use this value for the Y component, leaving the X component as 0. Then we'll output that vector into the offset slot of a new tiling and offset node. Use the hologram tiling property for the tiling slot and leave the UV alone. We'll output this to a simple noise node's UV slot and use noise scale for the scale slot. The final step is to add the noise to the scanline texture. We need to shift the range of noise values from between 0 and 1 to between -0.5 and 0.5 by subtracting 0.5. Multiply it by the noise strength and then add it to the scanline sample texture from the previous tutorial. We can then feed this into the existing add node from the previous tutorial instead of using sample texture directly. And with that, we've successfully made our hologram look worse, in a good way. The imperfections make it look as if there are transmission issues or some other kind of instability as you might expect with this technology. As always, thanks to my Patreon supporters. The highest pledges are on screen right now. These videos wouldn't exist without your support. If you've learned something, please consider subscribing to my channel or sharing these videos with other game developers. See you next time.